So we have an integration 0 to 1 ln x upon square root 1 plus 1 minus x square dx, right? So what is the idea for solving this integration? So this integration asking just happening MIT B integration semi-final exam. Okay. So the integration, so what we can write, so we write I is equal to uh, integral 0 to 1 ln x upon square root. We are taking here x common, so that is x 1 minus x dx, right? Okay. Now we substitute, you put x is equal to sine square theta, okay? Sine square theta. So that is, now we differentiate it, so that is dx is equal to 2 sine theta into cos theta d theta, right? Now we put this value on the integral, so that is I is equal to integral 0 to 1 ln sine square theta upon uh, square root sine square theta 1 minus sine square theta, and that is dx is equal to 2 sine theta into cos theta d theta, right? So that is 2 sine theta cos theta d theta, right? Now integral I is equal to 0 to 1, that is ln sine square theta upon, this is sine square theta and 1 minus sine square theta cos square theta. So and square root, that is sine theta into cos theta and 2 sine theta into cos theta d theta, right? Now I is equal to integral 0 to 1, and this is 2 ln, we can write 2 ln sine theta upon, this will cancel out, so that is 1, okay, here 2 d theta, right? That is 4 times, okay. Now on the next slide, so that is integral I is equal to 4 times integral 0 to 1 2 ln sine theta d theta, right? Ln sine theta ln sine theta d theta, right? Okay. Now what about the idea? Okay, that is the mistake. Actually we put also the limit here, so that is 1 sine square theta, okay, so that is pi by 2, right? So also limit will change pi by 2, so that is pi by 2, okay, pi by 2. Now so this is pi by 2, okay. So how to solve this integral 0 to pi by 2 ln sine theta d theta? What about the idea? Yeah, we can use here Fourier series transformation. So using Fourier series, so that is ln sin theta is equal to, we can write it a minus ln2 minus summation n is equal to 1 to infinite cos 2 n theta upon n, where theta belongs to 0 to pi, right? Okay. Now that we can write by Fourier series. Okay. So we are taking here integral. So that is integral 0 to pi by 2 ln sin theta is equal to a minus integral 0 to pi by 2 ln 2 d theta. Okay. So here also d theta we are missing there. So ln theta sin theta d theta is equal to minus 0 to pi by 2 ln 2 d theta minus, we are taking integral along theta, so that goes to in summation n is equal to 1 to infinite, okay, 1 by n integral 0 to pi by 2 cos n 2 and theta d theta, right? Okay. Now what about the idea? So minus integral ln 2, so that is l and 2, okay, and that is theta, so that is pi by 2 minus summation n goes to 1 to infinite 1 by n, okay, so that is integral 0 to pi by 2 cos n theta, so that is 1 by 2, so that is integral will sine 2 and theta and by 2n, right? And our limit is 0 to pi by 2, right? Okay. Now that is minus l and 2 pi by 2 minus summation n is equal to 1 to infinite 1 by n, that is 0 to pi by 2, okay, so sine pi sine n pi, okay, so sine n pi is 0, okay, and sine 0 is 0, so that will 0, okay, so sine n pi minus sine 0, okay, by 2n, and sine n pi is 0 for all integer n, right? So the integral will, so this quantity will 0, so this quantity will 0, so the whole this quantity will 0, so that is minus times ln 2 pi by 2, right? So this value will be for this only, so the integral I is 4 times, okay, so the integral I is equal to 4 times integral 0 to pi by 2 ln sin theta d theta, right? So that is 4 times pi by 2 minus ln 2, right? So that is minus 2 pi ln 2, okay, so that is the final answer. We can calculate here. So this question was asked in MIT 2025 semi-final B integration entrance exam. Okay, so thank you.